All right, so my name is Boaz. I'm with MotherDuck, and I'm here to talk about what happens when you take another very good database and combine it with some cloud infrastructure and these beautiful machines that we all have in our laptops, in our bags, sorry. So before we go there, I want to start with some foundational beliefs of MotherDuck, like things that are very core to us and what we strongly believe. And you may have read these things circling around the internet. Obviously, it's a very catchy title, which helps it circulate around the internet. But that's not really, we don't really mean that there is no data anymore, right? And we don't have a lot of data, and if we would believe that, then I guess most of us here would just not be here. What we do believe is that while you have a lot of data, and I think people talk about it today already, the amount of data that you actually use is not that big, okay? And to recognize again a few data sets that were talked about today already, here's the, it's out. Here is a chart of an analysis by George Fraser, CEO of Fivetran, of the Snowflake data set and the Redshift data set for the amount of data those queries touched. And then, yes, you do have here the 1 terabyte plus bucket. Sorry, bot, that's probably you, asking for distributed scanning of lots of data. But most of us are much deeper in the lower end. And if you try to eyeball what's the mean of that data set, I would say 200 megabytes. That's basically where it aligns on. And if you allocate for 512 gigabytes, you're probably doing pretty well. You covered pretty much everyone. So that's what people really use. On the flip side, if you look and see what the machines that we use to do that are, and back in 2006, if you try to get a VM in the cloud, you will get something that's pretty much like an Apple Watch today. Okay? 1 core, 2 gigabytes of memory. That's it. So that's, I don't know, 18 years ago. Whereas if you look at the machines you can get now, it's 24 terabytes of RAM and 448 cores on a single machine. Of course, you need to be able to pay that. I don't know if I can. But if that's really important for you, you can scale all the way up. But the average machine that you can get is pretty significant, like 128 core, 1 terabyte. I think most of us use probably 64 gigabytes memory and maybe 32 core machines out of the box, just default, don't think about it. So it's been a huge transformation. And the same has happened with these compute devices that we have in the laptop, just one here at the edge of my fingers. Okay, so these things, two things happen. But if you look at the system that most of us build when we build our cloud data warehouse, they look like this, right? So there is a query master or a control plane, and it goes to all the workers that needs to do all the data. You need to shift data around, you need to process it, then you need to get it from somewhere, right? So it's quite complicated machine, quite distributed systems that are hard to maintain. So we solve that, we need to scale to those petabytes of database problem. But at what cost? At what price? What amount of complexity? That's kind of the question. And the thing we believe in is that when you go and look at what a single node can do these days, it's quite a lot. It's obviously simple, and I think I have the background to be able to say it. It's much simpler. It's efficient because you don't need to talk about network, you don't need to talk about exchange and how to do efficient shuffles, right? It's just simpler. And the main point here is that probably sufficient, actually highly likely sufficient, okay? So that's our focus, that's what we try to do. So that's one thing. And going from there, I'm going to focus on a single node database that I think needs no introduction in this room. Thank you. And this thing has a lot of great stuff, and all of them are probably true, but I want to focus on just one thing. And that one thing is that it runs pretty much everywhere. Okay, it's everywhere. This is a screenshot, a live website I just went there yesterday, where it uses WebAssembly and it runs in your browser, and you can type SQL into your browser, and going from there you can query Parquet, Iceberg, CSV, whatever is on the internet, just go at it. You don't need anything else, okay? In fact, it's so much runs anywhere that a certain person in the room was so excited that it can run in a mobile Safari that we had to talk about it at 3 a.m. in the morning in some random bar in Amsterdam. It does do that. We checked, okay? So this is pretty cool. This, by the way, really a random guy, which happened to be an application developer. I'm just saying. So, seriously. All right, so with that, MotherDuck. So We had this amazing we have these amazing machines at our fingertips, sitting just here. We have a great database to actually use them. Okay, what's the next problem? What don't we have, or we do have? The next thing around is data. Okay, so if you're in the type of place that mails CSV around, and you have your data, then you don't need anything. It's there, it's on your laptop, do whatever you want to do, and move on. But most of us likely have some data in the cloud. Okay, so we need something to do with something to get it off the cloud or to run it, and it's also just the laws of physics that if you bring the compute to your data, it will be faster. Depends on the compute that you try to do. So what MotherDuck tries to do is to take your DuckDB and enhance it with another DuckDB that's sitting back in the cloud. And our extension of what we do is when you type your SQL into your DuckDB, the same standard SQL, we will try to figure out where is the best place to run it. Do we want to run it on your laptop, or do we want to run it on the cloud? And if your data is on your laptop, MotherDuck has nothing to do, and it will run as it used to be. But if data is sitting in S3, we will route this request to MotherDuck, and all the initial processing, reduction, aggregations, filtering, whatever you want to do will happen next to the data, and you'll only get the results that you're after. And from there, you can iterate further. And we can also just figure this all out automatically. So if you have some of your data locally and some of the data in the cloud, we will join it for you depending on what's more efficient, upload, download, and do all these things. So that's MotherDuck in the short. Peter, how much time do I have? I have no indication of time.
5 minutes.
No, it's fine. All right, so we have all the ingredients, and now we can go back to what it's really about. So we have, again, laptop, database, cloud. What can we do? And I think the main point was that if I'm going to demonstrate it by just 2 examples. One is a Mosaic. That's a framework developed by Dominique and CMU. And that one is building a set of interactive charts. And the whole point that they are very interactive and they are very correlated to each other. So here's you have a set of a flights data set where the top chart says how many flights were in total. What's the distribution of a delay? The bottom one says what time did they leave, and the final one says how long was the flight, and you can drag and drop and circulate, and I have one demo to see how this is done. This is a stock chart where you have 3 stocks, and you can anchor the 0 point wherever you want, and it moves left and right, and everything is updated. Now how is this done? Because it's fully local, right? So here I'm using I don't know, 24 frames per second video to show 60 frames per second updates. So trust me. But the point is that all of this is local. There's no 200 millisecond overhead to go to the server, come back, just run all your compute, and then you get this wonderful interactivity. Here's another example. I assume I can get the browser to listen. There we go. So this is a chart of the weather types in a certain day in the month in a year, and you can see a season, 3 months, I think. In total, and you can zoom around, and on the bottom, you will see the analysis of how many sun days you had, how many fog days, and how many rain days. And if you look at this carefully, I think it's probably likely that this is Amsterdam. Okay? It's just too much blue. Actually, it doesn't rain here that much, but that's a whole different discussion. And then for the last part, the second example I want to show you is something a colleague of mine and some other people in the room works on, Hamilton, and that's instant preview mode, and that's using the same local interactivity to give you a much better IDE experience when you type your SQL to assist you. And I'll try to talk to it. It's pretty fast. But it uses a data set called SF911, I believe, which is in the US a set of a phone number you phone when you have a problem that's not urgent. If it's urgent, you phone 911 or 311. I forget. We'll see in a second. Point is that he looks at all those from San Francisco and what day they were resolved, how long it took to resolve them, and so forth. And as you can see, he types this query. And as he types, the data that is shown is immediately adapted. Add a column, remove a column, give the name to a column, or say, oh shit, I actually want the duration, let's do this, I want to normalize to days, we can do this. And as you type this, you immediately get feedback that you did the right thing. And if you combine it with something else more powerful, local inference, you can also say in this specific context, because you have a database to analyze all this query, in this specific context, I just really forgot how to use this regap thing. Please make it for me, right? And then you get it, you immediately get feedback. You say, oh, I actually need to rename the column again. I can play with it. Group by, again, all of this interactivity, and it's all made possible by the fact you do not need to go to the server, you can do it all locally. So that's the last example. Yesterday, Hannes talked about how putting DuckDB in the edge allows all kind of crazy stuff. This guy did it in his maternity leave, because he had nothing to do, and some people are special. So that's what happened. If you have something to do, but you're also special, and you want to talk about what you're doing with DuckDB at the edge, please come talk to me. I'm very interested. So that's my talk.